In the previous tutorial, we talked about mathematical operators, which allow us to perform calculations. But sometimes we want to know the result of comparing two values. To do that, we use comparison operators, and you may often hear these referred to as relational operators as well. On the website, you have an operators in JavaScript document. You can refer to that at any point in time that you wish. But our comparison operators are less than or equal to, greater than or equal to. Remember, in JavaScript, one equal sign means to assign a value. So when we want to check to see if two values are equal to each other, we either have to use the double equals sign or the triple equals sign. The double equals means it has the same value. The triple equals means it has the same value and data type. Most often we'll use this next semester. And then an exclamation point and an equal sign means not equal to. Okay, let's look at what some problems with this would look like. So let's assume that y has the value of 3. Is y less than 2? That is false. Y is not less than 2, so that's false. Is y greater than 2? Well, that would evaluate to true. Is y less than or equal to 2? That evaluates to false. Is y greater than or equal to 2? True. Is y exactly the same as 2? False. It is not exactly the same. And that's the next question. Is y not equal to 2? Well, y is not equal to 2, so that evaluates to true. Let's take another example. Often we may need to find a new value using our mathematical operators before we do our comparison. So how do we know what goes first? Well, you know the order of operations, or should know the order of operations from your math class, but what happens when we have both mathematical equations and comparison operators in the same equation? So on that same document where you have your mathematical, comparison, and logical operators, on the second page, it gives the order of operations for these. So for your mathematical operators, of course, the parentheses are first, then the exponents, then multiplication, division, and modulus, and then addition and subtraction. After you do that, then you can do your relational operators. So that's how you can evaluate something if it's less than, greater than, or not equal to. And those are evaluated from left to right. Okay, so let's take a look at this problem again. If we have x having a value of 1, y having a value of 3, and z having a value of 5, how could we evaluate this problem? Well, first, let's plug in those numbers. So we have a variable x having a value 1, z 5, and y 3. Now we need to do our math. Remember, we do mathematical operators before comparison operators. And I know from PEMDAS that I need to do my multiplication first. So 2 times 1 is 2. Then I can go over to the other side and do my subtraction. 5 minus 3 is 2. And is 2 less than or equal to 2? Yes, it is. So that evaluates to true. Now, looking at that same equation, let's change this comparison operator to not equal to. So if it was not equal to, and we had 2 not equal to 2, that is false. 2 is equal to 2, so it is false. These kind of trip people up sometimes, so just kind of say it out loud and it'll help you. Like, 2 not equal to 2? No, that's not right. That's false. We can not only compare numbers, which are numeric data, we can also compare string data. What happens if we had a variable that had a value of b and another variable that had a value of a capital B? Would little b be less than or equal to big B? Well, intuitively, we might think because this is a smaller letter and this is a capital letter, that may be true. But there's actually a way for us to determine this. Let's see if we can find these values for X and Y. If you think back to the very first week of school, that was so long ago, we had this project on this website. Do you remember where we talked about binary encoding? And we learned about ASCII. ASCII is the code that represents all our English characters and numbers. And actually, remember we said even now we kind of use Unicode. ASCII is a subset of Unicode, so they have the same values. But this is a way for us to compare string values because at its core, it goes down to represent a binary number. A digit is a binary number. And if we can find that binary number just to make it easier for us to a decimal number, then we can very easily determine which one is less than or greater than. Okay, this page is still on that website, so if you want to look at this larger table, feel free. But I'm also including this smaller table like this. The only problem with this smaller table, I like it, but you may get confused. So like this space is 32, not 48. So you kind of have to keep in mind because it's code char, code char, code char. So you got to kind of keep in mind that this code is with this character, this code is with this character. Okay, so now we just need to find the lowercase b and the capital B, and I happen to know that they're right here. And if we take those values and plug those in for X and Y, the capital B is 66 and the lowercase b is 98. So now if I use those values to compare 98 less than or equal to 66, well, that's false. That is false. Now, on your assignments that you'll have, you may have more than one letter. So let's say if we had this instance. So in the first case, the first letters are the same. So then we would go to the second letter and compare those second letters. Okay? Just kind of like how you would do alphabetic order. Okay, don't forget that ASCII chart is on that old website that we had in week 1. So you have to go back to week 1 assignments. And the order of operations, do your math first and then do your relational operators. So you have 2 activities for comparison operators. One where you're comparing mathematical data, numeric data, and one where you're comparing string data. Good luck.